Hi, good afternoon, students. How are you today? Okay, so let's start our lesson. Our lesson for this afternoon is about solutions. Okay, solutions. So here we just a quick review. When we say mixture, is a combination of two or more substances that do not combine chemically but remain the same individual substances and can be separated by physical means. So there are two types. First is heterogeneous and the second one is homogeneous. All right, so let's discuss through about heterogeneous mixture. Okay, hetero means different. Okay, so it consists of visibility different substances or phases such as solid, liquid, and the gas. Okay, so when we say heterogeneous mixture, it can be separated by filtering. Okay, it can be separated by filtering. For example, in this picture, there are different types of nuts. We have nuts, raisins, what else? Dried foods. Okay. So you can actually pick them one by one and you can identify them. All right. Next we have homogeneous mixture. Homo means the same. All right. So homogeneous mixture has the same uniform appearance and composition throughout. Okay. Only maintain one phase. It's either solid, liquid, or gas. All right. So a homogeneous mixture is commonly referred to as solutions. All right. For example, we have the salt water. Okay. The salt are being dissolved in the water. Okay, now let's have solution. Solution, a mixture of two or more substances that is identical throughout, homogeneous. It can be physically separated and composed of solutes and solvents. Okay, when we say solutes, that is the substance that being dissolved, while solvents is the substance that dissolves in the solute. Okay, so I have here a question. Salt water is considered a solution, and how can it be physically separated? What do you think? What procedure should we do in order to separate the salt from water? All right, we will do this activity on the next part. Okay, so here another picture we have the iced tea mix, which is the solute, and the iced tea is the solution. And then I am again, and then we have the water as the solvent. So if you are going to mix the water in the iced tea mix, it could be okay, it will turn to become an iced tea, and iced tea is a solution, right? Because the iced tea powder are being dissolved in the water. Okay, so the solvent is the largest part of the solution and the solute is the smallest part of the solution. Okay, so water is the universal solvent. Okay, so let's talk about solubility. Okay, the amount of solute that dissolves in a certain amount of solvent at a given temperature and pressure to produce a saturated solution. Okay, the factors that affecting solubility of solvents we have temperature. Okay, temperature. Increased temperature causes solids to dissolve faster. Okay, temperature. Next we have shaking. Okay, shaking or the agitation causes solids to dissolve faster. All right. And the last one is the particle size. So smaller particles dissolve faster because they have more surface area. Okay, take note that increasing the amount of solute does not increase the rate of dissolving, of course. Okay, so we have here the miscible liquids can easily dissolve in one another. Okay, immiscible liquids are not soluble in each other. Okay, we have polarity and dissolving. So chemists use the saying like dissolves like. Okay, polar, when we say polar solutes tend to dissolve in a polar solvents, while non-polar solutes tend to dissolve in polar solvents. So, for example, oil is a non-polar while water is polar and they are immiscible. Okay, so they cannot mix together, oil and water. Okay, so I guess that's all for today. And if you have more questions, we will discuss more in our um, class or online class as we have next week. All right. Thank you so much for today, and I hope you had fun and learned with our with this short clips. Okay. Sorry. Hmm. So that's all for today. Thank you so much, and have a good day. Bye.